Morning, dear students. Now, as we have seen about the chemical properties of benzene, in which we have discussed about different types of reaction: substitution reaction, addition reaction. In substitution reaction, we have seen about nitration, sulfonation, halogenation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. As well as in addition reaction, we have seen hydrogenation, halogenation, and ozonolysis. Right? So here we will see the mechanism of electrophilic substitution reaction. Mechanism, it means how the cleavage takes place and what transfers from where, because substitution, it means someone is substituted on the place of some other. So how it takes place, that is considered as mechanism. Now, according to the basis of experiments, substitution electrophilic reactions, SE stands for electrophilic substitution reaction or substitution electrophilic reactions, are propagating through three steps. The first is generation of the electrophile. That means whatever the reagents are added, from that the electrophiles and the reactants which are there, from the help of that reagent, the electrophile from the reactants is generated. The second step is the formation of the carbocation. That means in the benzene ring, on the carbon, the cation is formed. That is the intermediate step between. So, formation of carbocation intermediate. And at last, the removal of proton from the carbocation intermediate. Whatever the carbocation is formed at the intermediate step, then the removal of proton is at the last, and at last the reaction takes in a complete position. Electrophilic reaction means in which H of benzene is replaced by electrophile. That means the attack of electrophile will be on the benzene ring. Two way it will take. Here H is replaced and one more is electrophile directly attack on the benzene ring. Right? So let us see first generation of electrophile E+. During halogenation, when I say halogenation, it means addition of halogen takes place. So halogenation takes place in both the way, in addition reaction as well as in substitution reaction also. Right? So during halogenation, alkylation where alkyl group and acylation where acyl group. Here alkyl, that means alkyl, one hydrogen less than the methyl. Alkene, that is alkyl. So if instead of CH4 it is CH3 methyl, C2H5 ethyl. So when alkylation reaction takes place, in the same way acylation along with halide as well as alkyl, if ketone group is added, CO, CH3COCl, C2H5COCl, that means along with alkyl group and halogen group, when ketone group is added, CO group, then that particular substance reactants are called acylation. And when Friedel-Crafts alkylation and acylation takes place, then we can see the generation of electrophile. So during halogenation, alkylation and acylation of benzene, in the presence of reagent anhydrous AlCl3 or FeBr3, when bromination is taking place, which are Lewis acid, helps in the generation of the electrophile. Cl plus, Br plus, R plus, that means alkyl group, and RCO plus, that is acyl, alkylium and acylium ion. They are produced and combining with the attacking reagent. What is the general reaction? Let us see here. Generally, substance, this is a reactant, or we can say a substance. Most substance, they always have positive and negative form So here E is electrophile and Nu is the nucleophile. Nucleophile, being more negative, will try to drag the electrons on it. So, as they will try to drag electrons on them, nucleophile will acquire negative charge, and electrophile, as the electrons are donated, they will have positive charge. So, this is how the electrophile is generated. Thus, electrophile generates from hydrolytic breaking with nucleophiles by the use of special reagents. This is hydrolytic because E is something else and Nu is something else. So, hydrolytic cleavage of nucleophile by the reagent. So, we'll see what reagent. With the help of that reagent, the further reaction proceeds. So, this was the general. Now, let us see. For halogenation, chlorination reaction. Halogen, that means fluorine, chlorine, bromine, iodine. So, let us see for the chlorination over here. Benzene, when reacts with chlorine in presence of AlCl3 and hydrous. So, this is the reagent. A special reagent which helps in the hydrolytic breaking of the nucleophile. So, this Cl2 directly, the cleavage on its own will not be possible because both are similar. So, both are having the same characteristic. So, here cleavage on its own is not possible, and that is why anhydrous AlCl3 is used, which will act as the intermediate. Now, as soon as AlCl3 acts with Cl2, Cl3 along with air will try to drag the electrons on it. So, this Cl with the electrons will combine with AlCl3, giving rise as AlCl4 minus and Cl plus. So, this is your chloronium ion. This chloronium ion positive will try to replace H plus from the benzene and will replace this hydrogen and will take the position over there. So, H plus proton is separated over here. This H plus will react with the another chlorine, this one, right? It will react with the chlorine of AlCl4, this AlCl4. So, this H plus will react with the chlorine which has transferred here because this has already attached over here. So, this will be transferred. So, this H plus will react with that Cl and give back the reacting reagent AlCl3 and byproduct HCl. So, once as I told that whatever the reagent is used as a promoter, as an intermediator, as a catalyst, will not exist out as any product. They will just give a promotion to the particular reactant for the further reaction. So, here you can see AlCl4 minus will give one Cl back to hydrogen and AlCl3 will be back. And so, we have here chlorobenzene and HCl as the byproduct, but our main product is chlorobenzene. In the same way, when bromination takes place, benzene reacts with bromine in presence of reagent FeBr3, and so this Br will be given to FeBr4 minus and this Br will acquire positive charge, that is bromo ion, and this bromo ion will replace here hydrogen which will react with one of the Br over here and it will be separated as byproduct hydrogen bromide, and this is your bromobenzene. So, this is how the halogenation mechanism takes place. We just read on this is the reaction. This is the reactants, benzene and chlorine gives the chlorobenzene and byproduct. But initially what takes place between this reactant Cl2 reagent used as a catalyst, how they both are reacting, how chlorine goes and sit on this hydrogen and where this hydrogen goes and what is the byproduct. That is called the mechanism. Same thing takes place with bromination. The next is Friedel-Crafts alkylation and acylation. Here see benzene when reacts with alkyl chloride, right? Ca3Cl. So it is alkyl chloride, that is alkylation. It is also taking place in presence of AlCl3 anhydrous, which will give CH3, that is methylbenzene on the benzene ring, and that is why it is methylbenzene. Its common name is toluene, and the byproduct is HCl. Here what happens? CH3Cl, which is the reactant of benzene, will react with the catalyst AlCl3. Here also, out of CH3Cl, Cl being more negative will try to drag electron and will combine with AlCl3 as AlCl4 minus. And here, as electrons are dragged away, it will acquire positive charge. So methyl group is with positive charge. This cation will replace the hydrogen from here and will take position of this hydrogen as CH3, and this hydrogen from here will react with this chlorine which has come to AlCl3 and in AlCl4, and it will be byproduct HCl. Now about the acylation. In acylation you see the reagent is CH3COCl. As I told, alkyl halide with ketone group C double bond O is heated in presence of anhydride AlCl3 will give COCH3. This will give toluene. This will give acetophenone. CO group, so ketone group ONE. Phenyl benzene, and one hydrogen is removed from it. So it is now phenyl group. So acetophenone. And byproduct is here also HCl. You can see the intermediate mechanism. CH3 double bond O Cl. Here also Cl being more negative will drag the electron and combine to AlCl3 as AlCl4 minus, and this will acquire positive charge. So this CH3 double bond O with positive charge will try to attract this one of the hydrogen. It will be replaced and it will react with Cl here, and the byproduct is HCl, and here it will be COCH3. This COCH3 will be attached over here, which is considered the new product, that is acetophenone. So this is the mechanism of halogenation, Friedel-Crafts alkylation and Friedel-Crafts acylation. Now see the reaction of nitration. Nitration, it means there will be the substitution of nitro compound NO2 in the place of hydrogen. The electrophile nitronium ion N plus, that is NO2 plus, it is nitronium ion, is produced by transfer of a proton from sulfuric acid to nitric acid. So here how the electrophile NO2 plus is produced. Generation of electrophile, the first step we are discussing. So here the nitronium ion is produced by a proton from sulfuric acid to nitric acid. So what is here in the reaction? You see benzene reacts with concentrated HNO3. It is the reacting reagent, where the specialized reagent used is concentrated H2SO4. HNO3 acid, H2SO4 acid. For us it is acid. But here H2SO4 is reacting as acid and HNO3 is reacting as base. Let us see the mechanism. So in presence of H2SO4, when benzene and nitric acid is heated at 323 to 333 Kelvin, it gives nitrobenzene and aqueous medium. That is water is one more. We can say byproduct or just aqueous medium of the nitrobenzene. But how this takes place? So here is the mechanism. HNO3, H2SO4, reacting reagent, special reagent for the intermediate reaction. So HNO3 and H2SO4, when starts reacting, what happens over here? H, O with 2 pairs of lone electron, because oxygen has 1, 2, 3, 4, 5, 6 electron. 1 electron is shared with hydrogen, 1 will be with the nitrogen here, and 2 pair is here. Now this pair of the oxygen is transferred to the hydrogen of sulfuric acid. So it is said that transfer of a proton from sulfuric acid to nitric acid takes place. So this electron pair is given to hydrogen over here, and this hydrogen, as soon as getting the pair, it will attach on the oxygen by getting positive charge, because electron pair is donated. And then here it is SO4 minus, because this H plus is attached to this oxygen, and oxygen being giving the electron will acquire positive charge over here. So this is O plus and this will be HSO4 minus. This is the protonated nitric acid. Still you can see it is HNO3, but one more hydrogen with positive charges here, so it is called protonated nitric acid. This protonated nitric acid further cleave, and this bond is giving over here. So what happens over here? This positive charge will be taken to the nitrogen, because this bond is giving electron over here. So this positive charge will come on nitrogen, and this will separate as H2O. And this positive charge will come, because this is breaking over here. So it will come to nitro compound, and this is the nitronium ion. This nitronium ion will replace one H plus from benzene ring. This H plus is replaced and it will take NO2 position over there. This H plus will react with the left out HSO4 minus in the very first cleavage, and it will be back as H2SO4. So the one who is reagent, catalytic reagent, will take part as intermediate, but at last it will be regained back. Here H2SO4 is acting as acid and HNO3 as base. Now is the formation of carbocation, that is the intermediate. This step also determines the rate of the reaction. So it is called rate limiting step. How far the reaction will carry forward is also considered from this step, carbocation intermediate formation. Carbocation intermediate forms when electrophile attacks the benzene ring. In the first it was attacking, replacing the hydrogen. Here carbocation is formed when electrophile directly attacks the benzene ring. Right? So here electrophile, we know that generally we have written that E electrophile and Nu nucleophile is there. So this electrophile is now reacting with the benzene ring. As soon as electrophile is start reacting to benzene ring, this bond will break and will come on this position. Here now see what happens. Already hydrogen is there. All 6 carbon has hydrogen. So this hydrogen is there. And now when this bond is cleaved from here, this electrophile will attack over here. So positive charge will be left over here, this carbon, because bond is from this between these 2 carbon. So what we'll get here, see, this bond is removed from here. H is already there. So electrophile is attacking over here, and this positive charge will be now on this hydrogen. This will take place. Now you can see that this can undergo the resonance. This formation is called uranium ion. Uranium ion is unstable. Why unstable? Because now it is not having the nature of benzene. It has lost the aromatic nature of benzene. Because out of 3 double bond, alternate 3 double bond, one is now cleaved. Now if this bond is replaced over here, because it is after all benzene where the pi electrons are always in the continuation, so it may take place that this bond will take place over here. So this positive charge will not be here between these two, because this bond will come over here. So this positive charge will exactly oppose over here, and this could be the another. This bond will come over here, positive charge from here will run here. The another thing takes place that if this bond is delocalizing over this place, then positive charge will be here on the top. These are the 3 resonating form which can be considered H and E on the same position. Here H and positive charges delocalizing continuously, shown by dotted circle. Thus carbocation tends to resonate. This carbocation, it will tends to resonate. Continuously it keeps on resonating because it wants stabilization. As the triple bond has already loose over here, so it is unstable, and to attain the stabilization it keeps on continuously delocalizing, and that is gives the 3 resonating form by formation of carbocation. So this is how the carbocation is formed. And in the last step, removal of proton from carbocation intermediate. So in the second step, this was the carbocation formed, right? Having He, H, and this is the plus. So taking that carbocation from the second step, we can have, see here, EH on this carbon, H, and this is the positive charge over here. Now we know that from the first step we have electrophile and nucleophile. So this nucleophile having electron pairs, that means 2 electrons. Nucleophile, which is left out in the step first, it has 2 electrons which will accept the proton, right? So bond of that H will go back to benzene. When this proton is accepted, right, this is accepted by the nucleophile, then this bond will go back to the benzene, and thus here benzene will restore its third bond. We can see here, see, this hydrogen will be accepted, that is proton will be accepted by the nucleophile because it is having 2 electrons, and as soon as this will go here, the bond will take place back over here. So we can say that benzene is restoring, right? And this is the substituted product. Substituted because electrophile is substituted on the benzene, and the bond is restored back. The bond has restored back, and then byproduct, this H has come on the nucleophile, H plus and Nu minus will be the proton is removed from here. So it is removal of proton from carbocation, and proton is now with nucleophile. Thus electrophile is settled on the benzene, and hydrogen is settled with the nucleophile, and benzene is replaced by restoring its bond. This is how the 3 steps takes place. One more reaction in between was left, that is sulfonation. In sulfonation reaction, benzene reacts with fuming H2SO4. Fuming H2SO4, that means highly concentrated, which is also called oleum. Only H2SO4 is our sulfuric acid. Sulfuric acid in a fuming form, that is the oleum, its formula is H2S2O7. So HSO3 plus H2SO4 is the oleum H2S2O7. Benzene, when heated with this oleum, it will give benzene sulfonic acid, SO3H. When it is on the benzene ring, then it is called benzene sulfonic acid with water. This fuming H2SO4, H2S2O7. How it breaks? It breaks in SO3H plus HSO4 minus. This is positive and this is negative. And so this is the sulfonium ion electrophile. This sulfonium ion will replace hydrogen from here, H plus, and it will take its position. This H plus will react with HSO4 minus and it will be HSO4 minus and H, so it will be H2SO4. H2SO4 will separate sulfur trioxide. It will be removed and H will react with H2O as a water. Right? So this is how the sulfonation takes place by the reaction of fuming H2SO4 with benzene and giving heat to it. So these are all the mechanism. Actually, reactions we have already discussed in the chemical properties of benzene: halogenation, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. All reaction I have shown here also today, because if I will not show you the reaction, you will not understand the mechanism. So this is sulfonation reaction, this is the mechanism, right? This is the mechanism and the reaction which I have shown in the previous. This is the nitration reaction, this is its mechanism. Alkylation, acylation, that means the benzene ring, how they are promoting the proton from the carbocation, that is shown over here. And this is the reaction showing the alkylation and acylation. CH3COCl acetophenone, and here CH3Cl when reacts, it is giving alkylation, right? And this is the hydrohalogenation, right? So this is how the mechanism of substitution, electrophilic substitution reaction takes place on benzene. Thank you.